Hello, my fellow scientists. Welcome to this study whereby I want us to look at types of potential energy. Potential energy is an energy which your body possesses due to its relative position with a given reference. So whenever you are dealing with the potential energy, there must be a reference point which you are dealing with. Now, there are two types of potential energy, and a potential energy is an example of mechanical energy. So when we come to potential energy, there are two types. We have the gravitational potential energy, which I have denoted here by PEG, and in basically energy, it is the same as work done. And work done is given by force multiplied by distance. And when we are dealing with a body of mass m, uh, uh, so force will be given by the weight of that particular body, and every body possesses energy. So a potential energy, or basically gravitational potential energy, will be given by the force multiplied by the distance in the direction of in which the body the force is applied. Then basically gravitational potential energy is given by mass of the object, whereby mass is in kilogram multiplied by the gravitational force per unit kilogram, or acceleration due to gravity multiplied by the height of the object. The other type of potential energy is what is called elastic potential energy. This is the energy which your body possesses as a result of it being compressed or being stretched. Whenever you stretch a body like an elastic material, then there is the energy. The energy could be stored, or it could be used to stretch the elastic object. So elastic potential energy is given by a half multiplied by force multiplied by extension, whereby we can write it as half. W is the weight multiplied by extension. We can also give it as a Hooke's law. From Hooke's law, we have applied Hooke's law here, which says that force is equal to Ke. So this is K. It is half Ke squared. So where you have force, we will substitute it with the Ke. So you will have half K multiplied by extension squared. So half K is squared from Hooke's law. So let us look at an example. For instance, if you are given the mass as 20 kg and you are given the height is 20 centimeter, you are told a body of mass 20 kg is placed at the height of 20 centimeter above the ground, and you are given the acceleration due to gravity at that point is 10 meters per square second. Then you are told to find gravitational potential energy. So it will be given by mass multiplied by g multiplied by height, which is equal to, our mass here is 20 kg times height, which is 20, divided by 100. You divide by 100 to convert it into meter, multiplied by 10. 0 and 0 will cancel, so you have 2 times 2, which is equal to 40 times 10. 2 times 2 is 4 times 10, which is equal to 40 joules. Now, you can be told to give this answer in kilojoules. So, 1 kilojoule is equivalent to 1,000 joules, meaning that 40 joules is the same as 40 divided by 1,000, which is the same as 0.04 kilojoules. So when you are given the height or at which the object has been placed or moved with reference to the ground. To get the gravitational potential energy, you simply multiply by mass in kilogram, g, the acceleration due to gravity, and the height in meters, and you obtain your result. As simple as that. The next example is elastic potential energy. This other example here, we are going to consider a spiral spring, which was attached as shown here, and then you are told that the spring was stretched, and it extended by 100 centimeter when a force of 50 newtons was applied to that string. So the question is, you obtain the elastic potential energy. So elastic potential energy will be given by half multiplied by the force multiplied by the extension. Then you substitute, which is equal to our half. Our force which was applied is 50 newtons multiplied by extension. Ensure that the extension is in meters. So you have 100, you divide by 100 to convert it into meters. So you have 50 divided by 2, it will give you 25 joules. So that is the elastic potential energy. Alternatively, this question can be calculated by, first of all, you calculating the what is called the, from Hooke's law, F is equal to KE. So we can obtain spring constant K is equal to force divided by extension, which is equal to, our force is 50, our extension is 100 centimeter. So 100 centimeter is the same as 0. It is the same as 1 meter. 100 centimeter is the same as 1 meter. So divided by 1, which is equal to 50 Newton per meter. So our elastic potential energy will be given by half K E squared, where K is the spring constant. Then from there you substitute half our times 50. 50 is K multiplied by E. Our extension is 1 times 1 times 1. So clearly 1 times 1 is 1. 1 times 50 is 50. 50 divided by 2 is 25 joules. So you can see either method, it works. Either method which you apply, it is going to work for you. So that is the end of our today's presentation, whereby we have looked at types of potential energy, and we have found out that there are two types of potential energy. We have the gravitational potential energy, which is given by this formula here, mass times g times height, whereby mass is in kilogram, g is gravitational due to gravity, and height is the distance from the ground to where the body has been placed, and it should be in meters. Then we have elastic potential energy, which is given by half force multiplied by extension, or it can be given by half K times E squared, whereby K is the spring constant and E is the extension, and the extension should be in meters. So thanks so much for taking your time to study with me about different types of energy. For more tutorials on energy, remember to like, also to subscribe, and to tune on the notification bell so that you continue getting other types of energy and how they are evaluated, and also other branches of physics which you have already dealt with, like linear motion and circular motion, and the other part which you are going to cover in the future. Kindly like and also subscribe to this channel so that you don't miss a single video which I upload every day. You can also leave your comment and share with us on how we can improve our presentation. so that you get maximum benefit as you keep on learning. So bye bye. See you in the next video.